Second video, we are going to see how to find the domain and the range of a function. But before that, we'll see another way to imagine the mathematical concept of functions. Say this is some machine and it's particularly designed to do certain process or job. And let's say this is a juicer and we are going to give some input, say some fruits we are going to put in from this part and you are going to get the juice. So that's a process being done over here, and for this process there will be certain design for this machine. In this part it's doing some processing work over here and give us the required output. The functions do a similar thing in mathematics. We'll take an example here. Suppose we have a function f of x equals to 5 times x plus 2, and you can say that this machine is like this function only. So I'll write f of x just to represent that analogy. And uh, the input is going to be some values of x. Say you can put 1, x equals to 1. What does this machine do to that thing now? That's the input. And it's going to refer this design or the definition for that. And the values of x goes over here. So 5 times 1 plus 2, that is 7. So this is the output we are going to get. 7 is the output. If you put some other value, say 2, then I'm going to get 5 2s are 10 plus 2 12. So I'm going to get 12 like this. So in a very similar way, this function works. And whatever values you can put here in this input part as x, all those values are called as domain. Okay, but be careful. You can't simply put all the values in it. Like the machine which we have seen. We'll go back to that machine again. This machine is used to extract the juice of from the fruits, but it may not be used for certain fruits. Okay, so we are not going to use it for sugarcane. So sugarcane is not suitable for this machine. Similarly, in a function you can't put any value. There may be certain values of x which are not allowed here, and for these values we say our function is not defined. We'll take an example. Maybe here in this function all the values are possible, but it's not the case every time. Let's see. Let's consider this example. Here f of x equals to 1 over x minus 3. You can put almost every value at the place of x and you're going to get corresponding values of f of x for this. But when you put x equals to 3, what happens? What happens to of f of x's value? It's 3 minus 3. We're going to get 1 over 0. So what's the problem with that? This thing is mathematically not defined because you cannot divide any number by 0. Okay, so just be careful here. You cannot have 0 in the denominator. So for those values where for which the value of f of x is not defined are not considered in the domain of this function. Then means if you ask me what is the domain of this function f of x equals to 1 over x minus 3, I'll say it's defined for all the real numbers except 3. So the set of all the real numbers except 3 is my answer. This is the domain of our function this. Now what you have to say every time whenever there is a function given, you have to find out what all the possible values of f of x, or this can also be called as y, what all possible values of f of x, or sorry, x, you can say, for all possible values of x for which f of x is defined are considered in a set of domain. Okay. Consider another function. Say this is a real function f of x equals to root over x minus 2. And here also you get for some values of x, this function will become not defined. Like you just have to observe this thing that there is a square root over here and you cannot have a negative number under this root sign. So for what values it becomes negative? It's very simple to understand. See, if you put a value, I don't know, greater than say 2, it is going to be positive always. So It's okay. 2 you can put, more than 2 you can put. What about less than 2? If you put a value less than 2, say, I don't know, 1. If you put 1, what is the answer? Answer is going to be root over 1 minus 2 as square root of minus 1. Now again, there is a problem. If this is a real function, you do not have these things. You cannot have a negative number under the square root sign. So this function f of x cannot, in fact, in this function f of x, x cannot take the values which are lesser than 2. Okay, so the domain is kind of a set of all the numbers from 2 to infinity, all the real numbers you can say, and you can put a bracket like something like this, which just tells us that this 2 is included in our set, and 2 to infinity, all the numbers, all the real numbers are there from in the number line. In most of the situation, you will get these two conditions only, that our function is in the form of a numerator and denominator, and here there is some x, say x minus 5, and f of x equals to square root, and you have some situation here, say x plus or minus 5, whatever you get over here. You just have to observe that for what values of x this is going to be not defined. You don't have to consider those values. Oh, sorry. Okay. You don't have to consider those values for which this f of x is going to be not defined. All other values may be possible. So here again, this function has a domain of all the real numbers except the number 5. So you can write it like this, all the real numbers except 5. And here again, this is going to be a situation like the examples we have seen. They should not be negative. Just be careful that this is not going to be negative. So I think again, for all the values greater than 5, including 5, are valid here. So 5 to infinity is the domain for this. These are all the possible values of x over here. When you usually see a function, they always denote it like this. F is denoted as R to R. What does this notation mean? This R means this is your domain. You can pick any value from this R as input, and the output may be from this. Okay, yeah, the output will be from this. Definitely it will be from this, but not all the values. So there will be some values from this set which will be called as our output. So this set we will call as our codomain, and the exact values which are possible over here are called as, which are present in this codomain, are called as the range. Every time a function will not be defined for all the real numbers to all the real numbers. Let's consider an example for that. Here I have taken a function y equals to root over x. Y, or this can also be written as f of x equals to root of x. Now, is this a function? Yes, it is a function when it is defined from the values like this, for all the values are positive to r. This function is called as a square root function, and only positive values of real numbers are considered here. So if you observe the graph, it's going to be like this. It's only defined for positive values. What if you take x is equal to minus something? See, in this region you go here in our coordinate system, where we are going to take the negative values, then nothing, this curve is not there. So it is not defined in this region. This is the domain. This is the range. The function is only defined for positive real numbers. So we write it as R positive. So along with your function, you're going to get this thing also. It's a package. You get this thing with it, and you can refer to this thing and say, okay, this is R positive, so my X can only be a positive real number. That is the domain. We'll consider an example where we'll find the range of a function given by y equals to x minus 2 upon 3 minus x. The domain is very obvious over here, as we have seen in other examples. This denominator cannot be 0, so x cannot take the value 3 actually, for which the denominator is going to be 0. All other values are possible, so the domain is simply all the real numbers minus 3. Okay, we'll see how to find the range now. For range, like we have this function as y equals to something in the form of x. Similarly, using the same equation, obtain what is the value of x from this. So I'll just do simple mathematical things over here, which is I can just do it like 3y multiplied by 3 minus x equals to x minus 2, and then this is going to be 3y minus xy equals to x minus 2, and I'm supposed to find the value of x now, so I can do like 3y minus oh, this should be minus sign here, like this. Okay. And I'll take this to this side, so it is going to be 3y plus 2 and x plus x times y. You can have this x as common thing, and we have this 1 plus y remaining here, and you can send that 1 plus y the other side. So 3y plus 2 on the left hand side we have, and you can take that 1 plus y in the denominator. That's the value of x we are going to get. This is what you have to do to find out the range. You find the value of x first. Now we will use this value of x to find the range. I'll just rewrite it again here. This x equals to 3y plus 2 over 1 plus y. Now you just have to see for what values of y this x becomes not defined. And again, since it is in the form of numerator over denominator, we'll just see for what value of y the denominator becomes 0. And it's clearly, if you put y equals to negative 1, you're going to get 1 plus minus 1 is 0 in the denominator. It's going to be not defined. So for this function, y cannot be minus 1. So what is our range now? Since you have found out a function in terms of x equals to something in terms of y, therefore this value is in fact the set we are going to find now is the range. So range of this function is going to be set of all the real numbers except minus 1. So we took an example where we found out the domain as well as range, and this is the best method to find the range of a function. In the next video, we are going to see some special functions.